Hi, in this video we'll talk about how to find or how to calculate the frequency response of a system defined by its numerator coefficients and the denominator coefficients. So open MATLAB. In MATLAB, first we will define the numerator coefficient by num, and we are taking an example of like 1, -1 and 3, and the denominator coefficients as 1, 1 by 3 and 1 by 6. Frequency response of the system can be find out by the freqz command. This command returns two values. One is the response of the system and other one is the frequency components. So we will take the response in h value, the amplitude response, and the frequency information in om values, and then freqz and the numerator and the denominator. That's it. Now we will try to subplot it, like subplot 211, and we will plot the amplitude response. And for amplitude response we are, because representing the on the x-axis will be the frequency, so ohm upon pi to make it a complete normalized frequency, and then amplitude will be in dB terms 20 log 10 absolute of h. So amplitude response will be plotted here. This is the amplitude response of this corresponding system. We can also plot the phase response of the system, and that can be defined easily by we will do it in the second plot 212, and then plot again ohm upon pi, comma, the angle part, because the phase information is represented in the angle portion of the frequency response of the system of h. And for checking it, so this is the frequency response, and the cutoff frequency is near about 0.5, because the amplitude or the phase response is getting a 180-degree phase shift at this particular frequency. So this particular transfer function can be termed as the high pass transfer function, because the lower component of the frequency below than 0.5 are getting attenuated, and then the frequencies above 0.5 are getting amplified. We can take another example, suppose our numerator part contains only 1 and the denominator part is let's take 1 2 1, and let's see how the frequency response looks like. So of this system, frequency num comma denominator, and then subplot 211, and then plot ohm upon pi 20 times log 10 absolute of h, and we will also plot in the same command the phase plot 212, then plot again ohm upon pi and a angle of h. So in the same command we have plotted the amplitude response as well as the phase response of the system. So this is the amplitude response, and it is a acting as a very high pass filter, and the frequency response no sir, because I have taken this numerator and denominator value randomly. You can verify this term for a specific numerator value and the denominator value, and then you can verify the theoretical results to the practical implementation result. And so that will be really helpful in doing some assignments based on the frequency response, or some questions in control system, like whether the system is stable or unstable. So that's it for this video.